Hello, welcome everyone to another episode of Crypto Convos. My name is Berk, and today I have with me a very exciting guest, John Stewart, the former risk and trust officer at Cisco. John, I'm so psyched you're here. Welcome.
Ditto, Vince. Thanks for having me aboard. It's going to be a good couple of minutes to chat.
Well, let's hope so. So, look, John, typically these conversations are pretty free-flowing. The first thing that's been on my mind lately is sort of this concept of technical debt, but then in the infrastructure. And since you spend a lot of time at Cisco, you understand cybersecurity. Cybersecurity is driving a ton of actual infrastructure decisions, if you will. I've always been a product guy. In product organizations, we like to talk about something called technical debt. The idea that you want to have features in your product, but you also don't have all that much engineering resources, so you sometimes cut some corners, and then you know that you're going to have to come back to that later, but it's never going to be quite the same, right? And so it's sort of a cruise, right? And then at some point, you're going to have to do a major overhaul to make this stuff better. And lately, in talking to people that run infrastructure in organizations, it sounds like that sort of starts to build up in organizations and infrastructure as well. Have you seen this? What are your thoughts?
Well, I suppose we could blame the product guys for all the technical debt that we have in operations then, right? It's actually a twofer. Part of it is that in most experience that I've had, there isn't a life cycle towards building something and operating it. You build it, you operate it, and then at some point or another, somebody figures out it's got to be modernized, it's got to be replaced. And somewhere during the duration of operations, product features, new versions, et cetera, like you were just speaking about, all come out. So there's the technical debt that's actually built into the product, which isn't intentional. It's just a function of go to market and, COGS costing and profitability. And then there's the technical debt after the product or service is being installed and then operated, which is its life cycle all the way through. Here's the rub. The rub is, and this has been true forever, is the operations team goes to budget for the installation, not the life cycle. And so consequentially, there's not sort of built-in annuities that say, we're going to have to maintain this, we're going to have to upgrade it, we're going to have to continue to improve it. And so it's a one and done, and then, essentially there's a run rate that has to be figured out later. That's not the way to do it in my estimation. It's what causes, in some cases, this technical debt, because the life cycle cost of the entire operation of what you're going to be using the service for isn't built into the budgeting cycle, so that it goes multi-year. And then last but not least, and certainly last but not least, we have a tend to build on, and pretty soon you've got too complex a stack that's all trying to be maintained, and the interdependencies of those become the technical debt. So you have an operating system upgrade, that's great if the middleware that's running on top of it can be upgraded with that version, if the application service that's running on top of that middleware can actually be upgraded based on the operating system. You got three different vendors, all of which have to agree you can actually build it. Good luck. And that's how this world works. It's nonsensical in some respects, and it sure as shoot shouldn't be done this way anymore, but we're going to have a heck of a time shift in the paradigm.
Yeah, I think that's right. Like me having spent a lot of time in sort of, security and visibility, right? Like the intersection of those two areas, right? The moment you give someone visibility into something they didn't realize that was happening on their network and their security environment, right? They never want to let go of it, right? Like it becomes part of the fabric, part of the furniture of the security organization, except that, well, there's always more things we can go and see. And so what ends up happening in enterprises is you end up with processes being built around visibility that is now available. The moment you try to sort of upgrade or change or move to a new product suite, then that automatically becomes the feature set that you're now looking to fill, right? And so the processes are actually the thing that are very, very slow to move. Let me see though about this, because I feel that in the world of infrastructure, like what ends up happening is the people that drive the infrastructure upgrade processes, and with that now a lot of the security posture, right? Like the segmentation, the filtering, what have you, right? The life cycle of those individuals in the organization is often shorter than the products they acquire, right? This is a reality of of what's happening, right? And so So you end up with like an enormous amount of patchwork, right? And what I mean, even in the routing space, this happens. You implement a whole bunch of the Cisco gear that you're well familiar with, and then all of a sudden, somebody is okay. Well, now it's time to upgrade to SD-WAN, but we can only do this for the branch locations because we just did data centers. They're good for a time being, right? And so you end up with multiple generations of technology that's often not interoperable, needing to be maintained and operated, right? And that's sort of what how do you feel about that?
You've actually just hit on the complexity problem that I think is the core of technical debt in almost every single situation. Um, the the real heartburn for trying to do the right thing today is knowing very well that the tech stack may well outlive you as an executive or as an operator or as an individual contributor, and somehow ensure you don't lock the future in a complicated way that can't be maneuvered out of. In a sense, saying, hey, I put these building blocks together, but I didn't put them together so tightly that the next thought process of the business, the next process of the person that comes into the leadership spot, or the next experience that people bring to bear, because say paradigm shift to cloud occurs and all of a sudden data center infrastructure is interesting, but it's not nearly as interesting as the future. How do you actually future proof this? And you're right, it outlives you and I and pretty much anyone else in almost all cases these days, small part because we don't spend 20 and 30 years like we used to in our whole careers in a single company. And the tech stack switches every, say 2 to 3 to 5 years, depending on what part of it. Yeah. So naturally, you have to install something new because it's new and it's the only version of it you can get, and yet it's what you need. So that lattice work then becomes all interconnected. Now, the final piece of this that's really, really unsettling is you become essentially technically dependent on people, because Vince knows those 5 things that were really big and they work well together, and he's the only person that fully understands it, equals Vince decides to win the lottery and then, no longer is working. All of a sudden you've got this massive, right? I'm sure you're good with that one. I think he won the lottery already. I mean, you're working for a great company, you're great people, but that's another point. But you end up being dependent on you, and then you decide to win the lottery, leave, and then there's this gap of experience. Not unsurprisingly, that either turns into its own tech debt, it turns into its own problem because it's not being maintained because no one really, really understands how it's working. Or it turns into, well, now that Vince is gone, we actually have to upgrade everything because we don't know how this works. So we got to go get another thing that actually works, that we know how it works. And this cycle, in some respects, it's almost like Groundhog Day in some ways, because this is happening again and again and again.
Yeah, I think, and so obviously this is a conversation about cryptography. So I'm gonna come back to that in a minute. But let's in that same vein talk about this thing that I, in prior parts of my career have seen quite a lot, which is the legacy application. And let me tell you what I mean by that, right? So we've seen, obviously, like with a lot of this kind of churn of certain products, right? Like there's obviously as a service offering, and then it's somebody else's problem to maintain the email server and the the storage and what have you, and that's great, except that, well, in an average enterprise, it's not, you'll see 800 applications run. And so what ends up happening is, the first 10 of those is a SaaS version, and all the others, well, some of them were in-house, some of them were truly legacy applications, right? And they can't easily, right? That's where 90% of your effort goes, right? Like, obviously, right, the 90-20 rule, the 80-20 rule, what have you, right? The point, though, is that those applications are there and they become legacy, not because they're bad. They become legacy because they're good. They're doing something for the organization. Now, where I am slightly fearful or should I say scared about, right? Like these applications, and think about regulatory sectors. Like think about, the Monte Carlo simulations, the bank runs, right? They're often built by someone who really, really knows their stuff. That application is working well. This is how we ended up with mainframes. We still have mainframes for this reason, right? As we go along decade by decade, this problem will compound because the fast, fantastic containerized applications of today will be the mainframes of 2 decades from now, right? Obviously, these mainframes exist because we want to continue running those. These applications are working for us, but they're not updatable. They're not fixable, right? This is essentially the compounding problem. As I'm looking at an organization that is constantly innovating, 2-3 year cycles, right? Sometimes longer, as you indicate, but often not, right? How do I get ready for that, right? Like, it almost seems like house cleaning isn't even possible anymore.
So there's two categories in my mind of that question, Vince. The first is core to the entire operating business of the business you're in. That would be the Monte Carlo simulation financials. That's a core service that may have to have a technological evolution, but it's never going to quote unquote go away because it's critical mission to the entire operation of the organization. Part of the reason I say there's two categories is because there's this other category, which is hold my application tight. And that one's the one you got to get relentless on. And here's a couple of ways I think this could change in the industry. And by the way, we're, allegedly we're the adults in the room, God help the world, because we're the ones that are the adults. But if we are actually to reward retiring applications as much as installing them, or services as much as installing them and launching them, then you'd see an entirely different shift, because it would be an equal part measurement of the results of the services operation that's delivering for the business, number one. Number two, if you could actually cost equation how many users and their vitality of the company using a service, and then measure that pro forma to every application, you'd start to notice that 5 people are using something that's extremely expensive, and yet it's still vital. So how about modernize it in a way that actually either retires it or puts it on a more modern stack or what it is, so that you can begin to essentially retire or replace or modify up to the latest generation. Also not done in a disciplined way. And the last one that can never be underestimated, and I think is in some cases the root of all evil, is the dirty little secret in many cases of most companies is their tech stacks are working, but they're not entirely sure why. And I give you the following proof point. When something breaks, all hands on deck start experimenting on how to restore it back to service. First one, oftentimes, restart it. Don't know why it broke, but restart it. Well, that's alchemy. That's not science. Hey, reboot the system it's on. Same situation. Alchemy, not science. Hey, change something that doesn't seem to have everything to do with it, but let's see if that fixes it. Again, experimentation versus science. And most of the reason it has to occur is because the true depth of understanding on why this whole thing is actually working together is not clear. So you remove ACLs, you reboot a firewall, you restart a service, you reload an operating system, you patch it, God help you. You actually patch it in the middle of a problem, hoping the patch is going to make the fix, or the vendor calls up and says, oh, I know what that is. Modify the software. Well, you're changing all sorts of things simultaneously, or at least in sequence. And that's not architecture. The root of all evil is the lack of understanding and depth of the architecture that makes this all work. Once you get to these things, like you change it based on the fact that you're retiring versus installing, so you move the needle a little bit, you actually say, hey, let's cost equation the user community and their vitality and how much it's being used per user. And then finally, you actually say, I understand architecture so well that I know what's core versus context, or what's necessary versus not. And I think you get a different tech stack. The conundrum is no one is rewarded the way that they're rewarded for building new service. It's not like you get a patching budget. It's not like you get a retire applications budget. It's not like you get a simplification architecture budget. You don't get rewarded on the depth of understanding of how things are working. So all of the imposed or maybe influenced ways by which you get to good are not there in the way our industry works. And big surprise, you get what you reward, and this is where we are. We get the tech stack, we get the tech depth, we get the technical debt, we get the complicated architecture or lack thereof, and we get this sort of patchwork, as you point out, and it's never. I don't see it systemically changing until those moving needles end up going with the way we actually operate businesses. My opinion.
I think there's two major insights in there that I hadn't thought about that I'd like to point out. First is there's a cost associated with continuing to run the application as is, right? You always building new is great. I'm going to build new. Oh, but we'll just keep the old thing running too, because how big of a hassle is that? Well, not only is it a hassle, there's a cost associated with it, right? And the justification for continuing running it versus taking it down, right? That's a simple monetary equation, right? Like me collecting stuff, right? Like how most people's garages fill up. Well, the cost associated with it is you can't park there anymore. Okay, right. So how big is that cost? Versus now, look at the enterprise, there's a cost associated with running it, updating it, maintaining it. But there's also a liability associated with it, which is the second point I think you're pointing out that I hadn't thought about. The liability is that it's probably old, it's going to break, it's going to get hacked, you're going to leak customer data, right? This goes back to the point, my traditional soapbox that I like to get on is like data is a liability. The moment you have data, at some point in a ransomware attack, that data is going to get leaked. So you have to very carefully think about the value of that data. If the AI model can ultimately mine some value out of it, how big is that value versus how big of a faceplant am I going to make when some ransomware gang puts it out on the dark web, right? So I like, anyway.
You're hitting a vital point though, the value equation around data. This is the hey, my photo library is so big, I'm upgrading my computer versus cleaning out my photo library with cats pictures and pictures, accidental movies of my foot, whatever in the world ended up happening. It is so much easier just to get another terabyte of disk storage, or SSD storage. So you might as well just do it that way versus deal with all that crap because it's hard. And that's true in the IT world, and it's also true in the data world, which is the data oftentimes is kept and preserved because, hey, we want to rerun a model on it later. But what do? We end up putting it in databases. We don't put it in near-term storage. We don't encrypt it or something or other that essentially means it's there, it's exposed, and it potentially has harm that can be created by it if something along the line of either ransomware or exfiltration happens. Yet we don't need it at this minute. And that's again, a discipline. Like, we don't need it right now. Put it in, so put it safely down on something. So we've got it, but it's not accessible unless we absolutely need it. And no one who copies it can have really the access, or delete it because the results are what the results are. We needed the AI or ML or large language model actually to do what it did. And now we don't need the raw data. We just need the results of the LLM. Again, it all comes down to the discipline of why do you delete stuff? Why do you turn stuff off? Why? And that's not typically the reward that's created for all of us in the operations side.
Yeah, but there's a huge amount of risk aversion associated with loss, right? Like, people don't like loss, and so deleting data means I lost something.
Right, but I'll give you a counter position on that in the product world that well. Deprecating features, same problem. Like, unless everybody isn't using something and you have the discipline to turn it off, and by the way, you find out that the feature you have is not intermingled with another feature that requires some of the same code, you're not going to turn it off. So you end up getting feature bloat over time, even though the user community isn't probably using it as much as they used to, or it was something from the 1990s or the 2000s, but you don't need it in 2023. Same kind of scenario in product development that happens in operations. And I know that having run both engineering and operations groups, I oftentimes get in trouble with each side when I say something like this, but I do believe it. We're actually a lot more similar than a lot of people are willing to admit. We've got similar problems. We've got feature, deprecation issues, application deprecation issues. We've got cost equation per feature. We don't understand exactly how the product works. I mean, we don't understand how the operations work. They're actually a lot more similar in the way I stare at them than I think both groups tend to want to admit.
I know. Well, so good. Well, the pitchforks are out, but I think the thing we always used to say, right, is performance is the currency with which we pay for features, right? So it's right. Like, if you think about adding features to product, think about what the impact of the performance of the product is, as opposed to, well, what's the engineering cost? Because the engineering cost I can calculate. Performance to the product, and therefore the experience that the user has, right? In the middle of a cybersecurity incident, I need to absolutely know who from this IP address in my organization talked to this IP address. And that question now takes twice as long. Well, those are very valuable minutes, right? So performance is a great.
But tell me, have you ever been rewarded for feature deprecation in your product development job ever?
No, of course not. Nobody counts that way. right?
Yeah. Nobody gets
So
rewarded for patching either until something goes wrong. And then they're like, what in the world? And why didn't you do that? And then you're guilty of something.
that's because it's all a long tail risk equation, right? Like there's,
Yeah.
it's much harder to calculate those the long tails than it is to calculate the Gaussians. Anyway,
I'm
hygiene
going to throw you a
aside,
softball. Let's switch it to crypto. Same
let's switch to
conversation.
crypto a little bit, so it stays a crypto convo. Look, John, um, one of the things is that if we look back at our Wireshark captures from about 15 years ago, a large amount of traffic on the network was unencrypted. HTTPS was finally just started to become a thing. Most people were still using regular IMAP or POP3 with plain text passwords flying over the wire, right? Now we've seen a variety of iterations of SSL, now TLS. For a TLS 1.3, there'll be a new one coming soon, right? So the point is, like, cryptography has evolved in those last 15 years. So we end up with applications that were installed 15 years ago that don't have crypto. They have crypto that's baked in, that's not going to get updated, right? We see this happening on the product side as well, where people say, look, I built this feature, it's great, but I can't really manage it. I can't scale it. So I'm going to containerize it, shove it in the cloud, Kubernetes, I can run it now. The problem is we access that through the old crypto that the thing is still talking on. And I think we're going to see more and more and more sort of this. Well, it's a sort of a tech debt, but then maybe a crypto debt, if you will, that is happening in the enterprises, especially pertinent to, I would think, IoT. How do you see this risk evolve? Do you agree with me? Do you think it's not going to be a big problem? We're going to run it in HTTPS, anyway? What's your viewpoint?
Well, there's already crypto debt. I know that for sure, and part of that's just traffic analysis at scale. That we've certainly done, even in my prior jobs, we ended up looking at kind of the overall exposure of what SSL versions are being run, what certificates are being well managed versus not. SSH version, 1.0, 2.0, 3.0. So even that, going back to the command line level, Telnet still being used on occasion, IMAP and POP3, like you mentioned, also having clear text passwords. This is another one of those scenarios, regrettably, that isn't rewarded. You're not rewarded to understand your crypto enterprise. You're actually, you have crypto. Most people don't fully process the differences between X and Y. If the lock shows up on the screen, everything's good. If I install it and it's the vendors, hopefully they did it right if it's good. And then after that, there's not a deep appreciation for just let's call it the enterprise's version, or if you will, the entire list of how it's done and that it's well maintained. Consequentially, I'll kind of go this way. First, I would hope that, frankly, crypto is considered a priority. Even if it's you're pushing vendors to say, look, we're not going to do this unless it's got crypto in it, and then hopefully rely on the vendors to do a decent job. Number one, and that's not even necessarily the case today, but that to me is Maslow's primary need. And then you can move all the way up to hey, I've got a full understanding of the estate and I'm maintaining it well, etc. I don't expect that in my lifetime, quite candidly, and I don't think you probably expect it in yours. That to be said, I place a big onus of this more and more on the providers, both the provider of product and the provider of service. And when they don't know how to do it right, IoT vendors in some cases fall into that category. Big companies, big vendors sometimes as well, or don't do it consistently. Then that's where I get frustrated the most, because they've got the most ability to influence the outcome, because of the built-in capability that almost inevitably is what we're talking about. IoT guys, thankfully, between power, memory, and CPU, those three things caused a lot of concerns initially. More and more are getting form factors in lightweight protocol that they can at least do a base level of encryption. So I consider that, let's call it not fait accompli, but essentially core. Move up from there, and it gets a little more complicated at line speed when you're doing, multi-terabit networking. That's where huge hardware and huge algorithmic, et cetera, starts clicking in. And last and certainly not least, and this is an agility point, we've relied on SSL since whatever it was, 1993 or something or other, when one of the very first versions of it came out. And I don't know if we have a really easy way to go, okay, SSL has got to be replaced by something else or augmented by something else in line at scale. So if something in that core breaks, I mean, truly breaks, we're going to have one heck of a time moving off what we've had before. DMVPN, same situation. IPsec tunnels, same situation. Over the air, SD-WAN, same situation. Those things are not trivial to replace at scale. And by the way, almost inevitably come as a surprise. Like, congratulations, the crypto's actually got a problem and you're exposed. Well, I didn't have that in the budget. I didn't have that in the schedule. Now what? Like, and I have to do it at scale. That like a big box company that's all around the globe, or a coffee maker that's all around the globe. That's a big deal. So I look to the providers of it, and then I think you would agree, you look to service providers as well in the prayer that they're actually capable of doing it at scale when we all need them to, because they're the ones that have the force de majeure to actually change it.
No, I think, well, certainly the fact that it has become a shared responsibility to do something about it, I would agree. I would agree with as well. I also don't necessarily see a very easy solution going forward as sort of this evolution continues to happen, because, right, like, and I'd like the example of the databases, right? Like, at some point in the past, we were writing applications where, well, if you needed to store something, you opened the file. Okay, well then you want to compile on Windows, and it was different, and and so at some point somebody says, well, you know what, we'll build this thing called a database. We'll have the SQL language. It's gonna be great, and I can actually now write my program and try a bunch of different databases. And in fact, if one of those databases and the indexes aren't fast enough, I might still be able to use the unmodified application with a newer version of my database and get better performance. And I've effectively modularized the storage, right? Mm-hmm. Network communications are very much not the case. Network communications are, well, they're done through a library that I compile in, right? And somehow that's odd, because you would say, look, you're already talking to the operating system for this, for this aspect of it, right? So anyway, I see an evolution that needs to still happen there, where the operating system that you run on perhaps takes care of the levels of cryptography that you need, while the application itself is simply dealing in plain text bits and bytes. But I don't think we're there. Well, I don't think we're going to get there.
I don't think we are either. But back to your point about legacy plus infrastructure plus crypto plus. Here's what I think is going to start emerging in our lifetime. There's going to be essentially a modified version of standard of due care. We see this in healthcare. I did everything right, but the patient died is reviewed and understood that you did everything right, but the patient died. That happens sometimes. I think what we're starting to notice in the IT and services world is like, you didn't do everything right and still got hacked. Like, you didn't pay attention. You didn't, keep a modern stack. You didn't actually care enough about the architecture. You didn't notice where your data was. You didn't care for it in the right ways. And that is going to come to toll. Like, the regulatory agencies around the globe are clicking in. Europe's kind of on the leading edge of that. UK is certainly part of that mix. The US is catching up a little bit, but certainly in Japan and others, they're starting to say, look, Vince, due respect, I know you're the victim of a hack. I get it. But you basically didn't even do the good stuff that modern version of 2023 says you should have done. So I can't just let you off the hook because you left the window open. Like, I mean, yeah, it wasn't smart. No, you didn't have the alarm set. But yeah, we got, things got stolen out of your house. Yes, you're a victim. I'm very sorry. However, you made it easy, for gosh sakes. So, like, don't do that. And I think that's where we may start to see a very interesting shift that, by the way, I hope has the downstream effects: retiring applications, cost equation versus use of service, the modernization to products. All of those things, I think, roll from there when we start to add up and say, yeah, enough's enough. And by the way, the security industry, I was a part of it. We didn't do this well on our own. We kept saying, don't worry about it, we'll do it. We didn't do it right enough. No, time to pay the piper on that one.
Yeah, and I think that's a valuable insight. And I want to kind of ask you one more question. I know we're kind of running up the time here, but recently, and so you know me, I have a background in AI and ML, spent most of my life in cybersecurity. Recently, I saw a super interesting article that talked about how password brute forcing. Okay, well, we can brute force things easier on a quantum computer, right? So we'll just wait for that thing. Well, so hang on a second. Most people pick passwords in some kind of logical way, right? A place, a date, a combination of that, like where they're placing the special characters, right? There are humanoid patterns to that. So, people took a simple neural network, right? You run through, you can go many locations and find many passwords that have been compromised from databases. So getting a good sampling of human generated passwords is trivial. You can get 1 billion of them, run them through, and then let that AI pick which passwords to try in brute forcing. And it significantly sped up the brute forcing, right? Because, well, we all pick passwords that follow these sort of human-like patterns. Obviously, I've spent a lot of time in the cybersecurity industry trying to apply machine learning to it. And often I felt like we were still significantly falling short of the capabilities we could exploit sort of like that, right? Because we're dealing with a human adversary, right? It's not a computer adversary. The computer doesn't go out to hack you. It's somebody at the computer that uses the computer to automate the hack of you, right? So a similar thing should technically be possible. I would say. How can we do this? I mean, how do you see AI evolve in the cybersecurity space? It's probably a super common question you get, but I'd love to hear your thoughts.
Yeah, this could be a podcast to itself. So maybe I'll get the good fortune of being invited back, and we can talk about that one as a whole. A couple of areas I see it already emerging. One, it's turning into a co-pilot for security operations people. Starting to watch the behavioral modeling of what people are doing repeatedly and then taking over and doing it on its own. I think that's a great use case. It's not necessarily the password use case, but it's a great use case for operators that need to scale because they're getting too much work to do anyway. So why not let a system pay attention to the expertise that they have and then essentially codify it in a way that can be reused without the person having to do it. Number one, it actually de-risks in some cases, because if Vince is the only person that knows how to do something, if we can actually notice how it's done and at least store it in some sort of technique by which it can be repeated without necessarily Vince being there, you can go on vacation. Again, you already won the lottery, so you're going to have great vacations. But then moving on to something like passwords, I've actually started to use interesting techniques by which to determine how to create passwords that have no connection to me whatsoever. Because it's kind of a cool reverse version of using the same thing. If you're going to be predictable in some way, shape, or form, which, by the way, almost all humans have tells, and that includes in password selection and like, why not actually say, what passwords do you think I would use, and see what ML can actually teach you, and then use something else. So yes, I've lived in certain places. Yes, I've gone and done certain things in certain times of years. Yes, I've got predictability that's public. Because of my experience, or places I've gone, or email addresses, or my initials are almost always my email address. So that's a predictable thing, right? Well, let's start using AI or at least ML models to go, give me something totally unpredictable that there's not a chance in the world it's going to be easy. And then go ahead and use it all you want. It's going to be harder for you to figure out because I'm not going to be tied to it. There's a guy by the name of Jeff there. He worked, and hi, Jeff, if you're seeing this. He worked in a whole bunch of work that related all the way up to and including at IBM. And he started being able to essentially say, you give me one piece of data and another piece of data about the same person, I can create the links in 7 steps, guaranteed at the most. That kind of trail of bits, if you will, that actually allow you to follow a person, that's the stuff we actually probably can use ML to undo and make it harder. So why not? Let's just use it for the positivity of it.
You know why I like this, John? There's something about the shifting the workload to the attacker thing, right? Like, there's a certain amount of things we do that makes it really easy on the attacker. And if we always think as the defender to make choices in such a way that the workload on the attacker is increased, the chances that they'll go somewhere else, right? So I like that.
And by the way, take it out of coaching.
Yeah.
Like, watch a coach where they start to realize what their own patterns are and what their own predictable items are. And they actually look at game film for a reason. They're trying to figure out predictable on the other side, and they're trying to pick predictable on their own side and then shift it. That's the kind of stuff we have to be smart about on both sides of the ball.
No, I think that's really good. So, John, is there any other thoughts you'd like to share? I usually ask that question.
Plenty, but we don't have that kind of time, Vince.
I appreciate that. Well, John, it's a pleasure. It's always a pleasure to talk to you. I learned something. This is the reason I go. I love doing these kinds of events, right? It's sort of like the highlight of my because you really can share ideas. I appreciate you being here. Hope you enjoyed it. Thank you very much.
I did. Thanks for being that kind of person that delivers these kinds of messages and discussions out there. It's super helpful, and I appreciate. Oh, and I appreciate you, by the way. Keep it up.
Oh, well, thank you so much. And thank you, of course, to everyone who views this. We'll be back again shortly with another Crypto Convos, and stay tuned. Looking forward to it.